Hi everyone, this is the fourth video, I believe, in the YouTube series for VBA help in numerical methods. This video will cover for loops, do loops, and we will briefly cover arrays. I'm not sure how in-depth we'll get into those in this video, but yeah. So let's start out with this kind of straightforward example to teach for loops, I think. We will be writing code to do a factorial, and so if you guys remember from calculus, factorial is basically you take the number that you're trying to take the factorial of and multiply it by every single number going down to 1. And so in this case, you can see I have 1, so factorial of 1 is 1, factorial of 2 is 2, and then factorial of 3 is 6, 24, 120, 720, and 50, 40, and so on. So to write this code, this is a very, very good example, a clear example of when you need a loop. So for the first one, we will be doing code to write for a for loop. So let's do function for, or let's just call it factorial. So in this case, we will need to have n as an input, because if we want to have a function and we want to have it spit out on the spreadsheet, we want to have an input. Alright, so first part of a for loop is you write for I equals 1 to, we could either say 1 to 10, 1 to 20, but in this case we want it to take the factorial, we want it to loop the number of times of the input that you are using. And so in this case, n, we want to loop for I equals 1 to n. And so this means it'll loop n times, or however many times you want to take the factorial of. So in this loop, let's just define that random variable that we want to use. Let's call it fact, short for factorial. And then in this part, we want to say fact is equal to fact times I. And I'll show you in a bit what that's doing. Let's define fact as 1 out here. So when it's looping through the code, or when it's starting to step through the code, it'll go to this top line, read the input n, go down to this next line to find this fake variable fact as 1. Then it'll go down to this next line for I equals 1 to n. It'll set I equals 1 in the first instance, and so it'll go inside of here. So fact equals fact times 1. The last thing in the code's memory that it remembers fact being was 1, because we defined it up here as 1. And so it'll take 1 times I. And in the code's memory, the last thing I remembered was it was 1. And so fact equals fact times 1. 1 times 1 equals 1, obviously. And the code will set that equal to fact. Now, when it goes into the next loop, goes down to next I, so it increases I by 1, so I is now 2. Goes up here, checks, I is 2. Let's just say, in this case, n equals 10, like we want to take factorial 10. N will be 10, I will be 2. It is not 10 yet, and so it'll loop again. So go into here. Fact equals fact. The last thing it remembers fact being from the previous loop was 1 times I. And in this case, after the second time it loops around, I is now 2. So fact equals fact with 1 times 2. And so now fact equals 2. Then I'll go down to next I increases by 1, so I is now 3, goes up here, checks I is 3, it is not 10 yet, so it'll go down here. The last thing I remembered fact being was, what was it, 2, so 2 times 3, and now that is 6. So fact equals 6, and it'll start looping, and I'll show you how it kind of loops in a second. Actually, before I do that, I'm going to just take this out here. I'm going to turn it back into a sub so I can step through, so you guys can kind of watch what's going on or see what's kind of happening. So I will step into it. Goes through factorial, sets n equal to 10, sets fact equal to 1, goes for I equals 1 to n, So in this case, it goes in, I is 1 because that's the first loop, n is 10 because I defined it as 10 up here. And if it was a function, I would have defined n inside of here. So, or inside of the factorial function. So now it goes into the loop. The last thing I remember is fact being was 1, I was 1, and so it'll set the product of those two equal to fact. It'll go down here, it'll reset I equals 2. You can kind of see how it went up. 2 does not equal 10 yet, so it'll go back loop inside. The last thing I remember is fact being was 1. The last thing I remember is I being, in this case, I is 2. And so it'll set fact equal to 2. Next I is 3. So the last thing I remember is fact being was 2. I is 3, so it'll be 3 times 2. And as you see, it looping through basically takes the factorial of each one until it gets up to 10, which is a really big number. So that is kind of the basic, very basic for loop. I'm going to turn this back into a function. There's other conditions that you will want to write in later. If you want your function to work, you will cover that or learn that actually in numerical methods in the fall, because this is actually a part of the first homework assignment. So I would save this code that you write for this, or save this little bit, because it'll help you on the first homework assignment. Anyway, so let's call this a function again. And let's go back and define the function, or set the function equal to, because remember with functions we have to set the function equal to something. Oh, not function, we have to set factorial, the name of the function, not actual function. So now factorial will equal fact. So in here, let's say n factorial from the for loop. And then, I don't know if you remember, but the nice thing about functions is that you can call them up in the spreadsheets like this. And so factorial, and I'm just going to enter this B column as the input. And if I drag this corner down, as you can see, we just wrote code to do the factorial for all of them. So let me just make this pretty. And then we're going to write a do loop now to do the same thing. Do loops, they have their pros and cons. In this case, they will not be as what is the good word, efficient as for loops, but they do have their place when checking for error, which you'll be doing a lot in numerical methods. I might get to that later, but let's just write another function. We're going to call this one factorial do. We're going to have the same input, and in this case, though, we're going to write a do loop instead of a for loop. So the syntax of a do loop, the main kind of syntax is just do and loop. And so for a for loop, it only will circle like a certain number of times. A do loop is a little bit more dangerous. It can sometimes keep looping because it doesn't know when to stop, and so with a do loop you have to define or make it stop looping inside of the code itself. And there's a couple ways to do that. I will cover a few of them here, but I'll just kind of leave that for other videos later, the more complexities of the do loop. So let's kind of set it up the same way. Fact equals 1. Oh, sorry, I forgot. The reason why I set fact equals 1 up here in the for loop is because VBA, if you don't define a variable originally, it leaves it as empty. And when you try to do operations, it'll treat that empty slot as 0. And so if I took this out and I ran this code, it'll say for I equals 1 to n, I equals 1, n equals 10. It'll go inside of the code. Fact equals fact times I is 1, so it'll be 1 here. But I do not have fact defined as any number previously. It'll be empty. And so it'll treat that as 0. And so it'll be 0 times 1. And so that fact will be 0. The loop up here, I equals 2, so 0 times 2 is 0. I equals 3, 0 times 3 equals 0. So I'll just kind of show you real quick what happens if I take out that. All of these turn to 0. And so and that is because it will like be called, or it'll think fact empty, or it'll treat it as 0 basically if you do not define it as 1 before. So let me just all right, back to here. So I have the same thing set up here with fact equal to 1 instead of 0. All right, and let's do the same. Fact equals fact times, let's do something actually a little different. Count. I will explain. Hold on a second. All right, so this will be slightly different. We have to define count in here because in this case, there isn't an I that is increasing with each loop. So we have to make kind of our own factor that's increasing with each loop. So let's do count equals count plus 1. And so in this case, we kind of have our own makeshift I that increases each time it loops. And so as we go through, actually let me set this back to a sub so we can walk through it. All right. And so in this case, it'll keep defining. I'll show you what happens. So we step through. Oops. That is not sub. There we go. All right. So in this case, we step through. N equals 10, except we don't use 10 anywhere. I'll kind of get to that in a bit. Fact equals 1. Do count equals count plus 1. You can kind of see how this is treated as empty. So it basically treats it as 0. So when it steps through, it's now 1. And then fact is 1. 1 times 1 is 1. Go down, loop up. Count is 1. And so 1 plus 1 is now 2. Go down here. Fact equals 1 times 2 is 2. And so it'll keep looping, keep taking the factorial, but it doesn't know when to stop. Because a do loop, you have to tell it at some condition to stop. And so it'll just keep going. And this will be kind of a pain. It probably will happen to you in the semester if you write a do loop, where it'll just keep looping infinitely. And so you can see here, it's already up to the 26th decimal, or the 26th power, and it doesn't know when to stop. It'll just keep going. So there are a couple ways to mitigate or stop that from happening. You can add either do while onto the do, or you can add a loop until. So do while count is less than n. So this is kind of effectively doing the same thing as for I equals 1 to n up here. Do while count is less than n. And so while count, so in this case, count, as we loop through, count will be less than n because in this case count is 0. And as it loops, count will go up by 1 each time. And once count equals 10, it will know that this condition is met, so do while, and it'll break out. I will show that now. All right, so n equals 10, fact equals 1, so do while count is less than n. Count is empty, so it treats it as 0. You could write count as 0 up above, but it basically treats it as 0 anyway. And then n is 10, so it is less than n. So now count equals 1 in the first loop, and fact equals 1. So fact is now 1 times 1. It'll loop, go up here, do while count is less than n. Count is now 1, so it is still less than n, so it'll go through, loop, take the factorial. Count is now equal to 3, or it should be, or 2, sorry. And so then it'll go in, loop, check, count is now 3, it's less than 10, loop, count is now 4 less than 10, 5 less than 10, 6 is less than 10, 7, 8, 9 is less than 10, and so now count is 10. So up here it sees count equals 10, this condition does not work, and so it'll skip and break out. So that is one way to mitigate or solve an infinite loop with a count loop. There's another way that you can do it. You can do loop until count is, let's just say, greater than or equal to n. I believe that is the syntax. It might supposed to be equal, greater, but we'll see. So goes in here, count is 1, And in this case, it tests when count is greater than or equal to n. That's when it knows to stop. And so it is not. So it'll jump back up here. Count is 2, 3, 4, 5, 6, 7, 8, 9, 10. And so in this case, count is 10. So that count is either greater than or equal to n, which we define as 10. And so it'll break out and stop. So those are the two ways that you can kind of mitigate or fix an infinite loop. I prefer do while, because you have the condition up at the top and you can see it, but it doesn't really matter. Do while count is less than n. And so what we can see over here, first let's change this back to a function. Take this out, take n out, and then put n back inside the function. And then because it's a function, we have to define the function as something. Alright. Oh, one other note. You can see how I'm using the same fact here and fact here. That isn't an issue because fact will reset itself after each function. And so there are ways. You can actually define something as global fact. And so if it goes between multiple functions, it'll hold its number or value. You don't have to know that. I may get to that in a future video. But know that it's all right to use the same variable in different functions. If you try to use the same function or the same variable within the same function, it won't work. It'll break. So let's call this n and then do, or n factorial then do, and then let's call it the other function, factorial do, and let's use the numbers in column B. And you can see it gives you the same value. And so in this case, we have factorial using two different methods, a for loop and a do loop. So that's kind of the basic for and do loops. I may make another video on those later, but I'm going to briefly cover arrays now. I won't go too in-depth into arrays, but I'm just going to give you a heads up or kind of what they are. So I'm going to make a new module just so it makes it less confusing. All right. And let's make this a sub array. Oops, doesn't like that name. Let's just call it my array. All right, I think array is an actual function inside of VBA, so that's why it didn't like me titling my function that or my subroutine that. All right, so arrays are a little bit confusing. If you can see over here, I have kind of a mini array set up down here. So an array inside of code, it's basically like you're kind of making its own little, I don't know the best way to explain this, but if you have a single or a one-dimensional array, it'll only take into account, or you can make an array with 5 different spots inside of it. And you can have one kind of variable inside of VBA, but have 5 different values inside of it. And so in this case, we could make an array for this top row, so 1, 2, 6, 24, 120, so the first 5 factorials. And then we can make a second array for 720, that. But there's this other thing called two-dimensional arrays. And so a two-dimensional array basically acts as kind of another spreadsheet or something inside of the code itself. And so in this case, our array size, or our kind of sheet size, is 5 by 2 or 2 by 5. And so you can have one variable inside of the code that keeps all of these values. And it's kind of confusing to put values inside of that array and then take values out of it, but it could save a lot of time and a lot of space and make things much more efficient inside of your code. So I'm going to just briefly cover arrays themselves. And so let's just to make it easy, let's just do n1. And these are going to be factorials, n2, n3, n4, n5. And so I'm going to set each one of these equal to the factorial, which is, you can kind of see I have, or the factorial from the array that I have in the sheet. 2, equals 6 equals 24 and equals 120. And so I can make an array. And if you remember from the previous video when I talked about dimensionalizing and dimensional variables, in this case you have to dim whether or not you have option explicit. Let's dim array1, and for arrays you have to have these parentheses, and then also you have to redim. I'm not exactly sure, I never figured out why, but you do basically have to redim it. So redim, and because we have an array of 1 to 10 or 1 to 5, I'm going to say 1 to 5 in there, and this will make sure it has 5 different places inside of this array. And so it has basically 5 different cells. So 1, 2, 3, 4, 5. So let's go through and define each part or each slot of the array. And this will be kind of confusing, but you can either say array1 equals n1, array1 equals n1, and in this case it'll say the first place in the array, that is 1 or n1. In fact, I could take out all of these values and just define it here instead. So array2 is equal to 2, array1 of 2, array1 and these values that I'm putting in here, the 1, 2, 3 right here, those are not, it's not taking the factorial of those. It's just saying these are the place, or this is the place inside of the array. So if I have an array with 5 cells going over, this will be what's in first space, and 2 will be in the second cell of the array, 6 will be in the third, and array1 of 4. This will be in the 4th place. Oops, I spelled that incorrectly. All right. And so now we have, once it goes through all of here, it'll define, and so basically this array1 will keep 5 different numbers inside of it, and you can call out those numbers by saying, let's just say range G6 is equal to array of whatever place we want to say. So let's just say in the 3rd place. So in this case, if we run sub, so the first place in the array is equal to 1, second 2, 6, 4, and so then 26, 120, whatnot. So the 3rd place in the array is equal to 6 because we defined it up here. It's still this one variable array1, but it has 5 different places, and I'll put in the sheet that equal to G6. I don't know why it switched modules on me, but anyway, so this is the basics of an array, and you can have 2-dimensional arrays. So let's dim array2, redim array2, 1 to 10 or 1 to 5, and the second is 1 to 2. So in this case we have 2 different dimensions. This is defining the first dimension and this is defining the second. So in this case 1 to 5, for if we want to kind of think about it in terms of the array I have over here, 1 to 5 that is the columns, and 1 to 2 that is the rows. It doesn't really matter in VBA, it just basically will give you kind of space to put values for the entire dimensional array. And so in this case, I'm going to do something a little bit more confusing. I kind of covered this in the last video, but I'm going to make a for loop for I equals 1 to 10, or 1 to 5, 1 to 5. Oops. Next I could say array 2 of I, comma 1 equals cells 16, comma I plus 2. And this is kind of confusing. Oops. So, sorry, this is kind of confusing. I kind of covered this in the last video, but so this is saying the first dimension of the array, basically the columns, it'll basically take the placeholder and set it equal to I. So in the first loop, I will be 1, so it'll be the first placeholder in the first dimension of the array. So, and that is equal to cells 16, because in cells, the first number is the row, so row 16, as you can see over here, and then I plus 2, actually that should be I plus 1. And so basically in the first loop, first I will be 1, 1 plus 1 equals 2, and so it'll be cell 16, comma 2. So 16, comma 2, so row 16, column 2, column B. So it'll make the first slot in the array equal to that. And then I can make second for j equals 1, 2, 5. Next j, array 2, j, comma 2. And this will be saying the second, so like basically the second row inside of this array, cells 17, comma j plus 1. And so, hold on, let me just kind of make a little divider, visual divider. So, in this case, as we run through the code, why does it want to run through that code? Alright. Why does it want to do this? Hold on a second. Sorry about that. I don't really know what it was doing there. But it'll go through and redefine this array 1, as we kind of briefly mentioned. So all of the parts in the array equal all of these. Here, a bit more confusing. It's more of a dynamic defining of the array. So in the array, cell basically 1, 1 in the array is equal to cells B16. So the first slot is equal to 1. Next is 2, comma 1. So in the second cell in the array, in the first I guess row of the array, is cell C16, which is 2. And a loop here, and this is basically defining the first column, or the first row, I guess, inside of this array 2. I'll go here and then do the second row. And so define every place in there. And so now, in our code, we have this array called array2, and it has all of these values stored inside of that one variable. So that's kind of how arrays work. I know it's very confusing, and it may seem very, very complicated. You're not sure how to really use them or how you're going to use them yet, but if you know how to use arrays, it can be very, very helpful, because if you can see here, I don't know if anyone knows any linear algebra, or has been exposed to any of it, or matrices even. This kind of looks like a matrix, and if you have a bunch of values inside of the matrix, or the array, you can basically do matrix operations or do calculations on the matrix inside of the arrays without having to reference the spreadsheet. But I will get to that later. I'm not sure yet what I will put in the next video, but again, in this video we covered for loops, we covered do loops, and we briefly covered arrays. I hope you enjoyed, and I hope this summer is going well for you. Thanks. Bye.